When dealing with categorical data with two or more distinct categories, and your goal is to determine if the sample proportion of a particular category differs significantly from a hypothesized proportion, a z-test for one population proportion can be applied. The z-distribution helps approximate the sampling distribution of sample proportions. However, this approximation is valid only if the sample data satisfy certain statistical assumptions. In this video, we will use a 5-step hypothesis testing procedure to analyze the impact of a new traffic signal on accident rates. A busy intersection in a metropolitan area had a history of high accident rates. To improve safety, the city's transportation department implemented a new traffic signal system with advanced sensors and timing adjustments. To evaluate the effectiveness of this system, they collected data on accidents at the intersection for 6 months after the implementation. Historical data shows that rear-end collisions accounted for 60% of all accidents at this intersection before the new system was installed. We will determine if the new traffic signal system has significantly reduced the proportion of rear-end collisions at the intersection. The formulation of hypothesis begins with defining the population, the parameter of interest, and the study's claim. In this scenario, the population consists of all accidents at the intersection within a defined period. The parameter of interest is the population proportion of rear-end collisions following implementation of the new signal system. The claim is that this proportion is now significantly lower than the previous 60%. Since this claim does not include equality, it becomes our alternative hypothesis. The null hypothesis, therefore, is that the proportion of rear-end collisions is not significantly lower than 60%. To ensure the validity of the one-proportion z-test, we must verify the assumptions of random sampling, independence, and a sufficiently large sample size. While the accident data is not from a truly random sample, we assume it is representative of typical accident patterns at the intersection. The independence assumption is reasonable, as each accident is a distinct event. Also, the large sample size conditions are met. Therefore, we can proceed with calculating the test statistic. To calculate the z-statistic, which measures the standardized distance between the sample and hypothesized proportions, we use this formula. Here, P is the sample proportion of rear-end collisions after the implementation of the new signal system, P0 is the hypothesized proportion, and N is the total number of accidents. Inserting these values in the formula, we get a z-statistic of -2.236. This z-statistic indicates that the observed sample proportion is 2.236 standard deviations below the hypothesized proportion of 60%. We will now use both the critical value and p-value approaches to decide whether to reject the null hypothesis. While both methods lead to the same conclusion, they frame the decision differently. The critical value approach defines a rejection region based on the significance level, the type of test, that is one-tailed or two-tailed, and the test statistic. We reject the null hypothesis if the test statistic falls within this region. Our test is left-tailed because the alternative hypothesis uses a less than sign. With a significance level of 0.05, we find the critical value from the z-table to be -1.645. The rejection region thus consists of all z-values less than -1.645. The p-value approach compares the calculated p-value with the significance level. For our z-statistic of -2.236, the p-value from the z-table is 0.0127. With the critical value approach, our z-statistic falls within the rejection region, therefore, we reject the null hypothesis at the 5% significance level. Similarly, the p-value is less than the significance level, leading to the same decision. Since we rejected the null hypothesis, at a 5% significance level, we conclude that there is sufficient evidence to suggest the new traffic signal has significantly reduced the proportion of rear-end collisions at the intersection. If you'd like to test your knowledge on this topic, Be sure to check the quiz link in the description below or visit our community page. Thanks for watching. Please like, comment, and subscribe for more statistics content.